Address Resolution Protocol or ARP. In this video, we are going to see address mapping, ARP, its operations and packet format. Address mapping. We may require to map between the physical and logical address several times. So many protocols will help us to do this. IP packets use logical addresses. These packets need to be encapsulated in a frame which needs physical address. ARP will perform this mapping, that is, logical address to physical address mapping. The reverse mapping, that is, mapping a physical address to a logical address, will be done with the help of RARP, BOOTP, and DHCP protocols. Lack of flow control and error control in Internet Protocol has resulted in another protocol, that is ICMP, that provides alerts. It reports congestion and some types of errors in the network or destination host. IP was originally designed for unicast delivery, that is, one source to one destination. With Internet, the need for multicast delivery, one source to many destinations, has increased. IGMP gives IP a multicast capability. Now let's see what is ARP, Address Resolution Protocol. ARP maps a logical address to its corresponding physical address. That means if the sender knows the logical address of the destination and it doesn't know the physical address of the destination, then the ARP will help to resolve it. Anytime a host or a router has an IP datagram to send to another host, it has the logical address of the receiver. Then the logical address is obtained from the DNS if the sender is a host, or it is found in a routing table if the sender is a router. The IP datagram must be encapsulated in a frame to be able to pass through the physical network. That is, the sender needs the physical address. The host to the router sends an ARP query packet. ARP packet includes the physical and IP address of the sender and IP address of the receiver, not the physical address of the receiver. It is shown in this figure. Because the sender doesn't know the physical address of the receiver, the query is broadcast over the network. Every host or router on the network receives the processes, the ARP query packet, but only the intended recipient recognizes its IP address and sends back an ARP response packet. The response packet contains the recipient's IP and physical addresses. The packet is unicast directly to the inquirer by using the physical address received by the query packet. In this figure, System A sends an ARP request with the logical address of the receiver, and the request is broadcast to the network. All the devices will discard the message except the System B, which matches the IP address sent by the sender. So the System B will reply with its physical address, and the reply will be unicast to the sender. An ARP request is a broadcast message. ARP cache memory. What is the need for cache memory in ARP? Using ARP is inefficient if System A needs to broadcast an ARP request for each IP packet it needs to send to System B. It could have broadcast the IP itself. ARP can be useful if the ARP reply is cached because a system normally sends several packets to the same destination. Before sending an ARP request, the system first checks its cache to see if it can find the mapping. Next is ARP packet format. So this is the packet format of ARP, which contains hardware type, protocol type, hardware length, protocol length, operation, and many addresses as its field. Let's see each field one by one. Hardware type. This is a 16-bit field defining the type of the network on which ARP is running, such as Ethernet LAN or any other type of LAN. We should specify the hardware type here. Next is the protocol type. That is, if it is running on IP version 4 or 6, that protocol version will be specified in this protocol type. Next two fields are hardware length and protocol length, which specifies the length of physical as well as IP address respectively. Next is the operation field. Operation field, it specifies whether the ARP packet is a request packet or a reply packet. So if it is reply, that field will be represented by 1, and if it is a request, if it is a request, it's represented by 1. If it is a reply, it is represented by 2. Next is sender hardware address and sender protocol address. That means the physical address and IP address of the sender respectively. Next two addresses are the target IP hardware address and target protocol address. That is the sender's, the receiver's physical and IP address respectively. If it is an ARP request, then the receiver's hardware address will be filled with 0 because the sender doesn't know the physical address of the receiver. ARP operation. What we have said now, we will be putting it in steps and explaining. In ARP operation, the sender knows the IP address of the target and not the physical address. IP asks ARP to create an ARP request message filling in the sender physical address, the sender IP address, and the target IP address. The target physical address field is filled with zeros. The message is passed to the data link layer where it is encapsulated in a frame by using the physical address of the sender as the source address and the physical broadcast address as the destination address. Every host or router receives the frame. Because the frame contains a broadcast destination address, all stations remove the message and pass it to ARP. All machines except the one targeted drop the packet. The target machine recognizes its IP address. The target machine replies with an ARP reply message that contains its physical address. This message is unicast. The sender receives the reply message. It now knows the physical address of the target machine. IP datagram, which carries data for the target machine, is now encapsulated in a frame and is unicast to the destination. So this is how ARP works. Now we are going to see 4 different scenarios where ARP works. First scenario is the sender is a host and wants to send a packet to another host on the same network. So we are broadcasting to a host on the same network. In this case, the logical address that must be mapped to a physical address is the destination IP address in the datagram header. You can see the 4 cases here. Second case is the sender is a host and wants to send a packet to another host on another network. In this case, the host looks at its routing table because the host is on another network. The receiver is on another network. So it finds the IP address of the next router for this destination. If it does not have a routing table, it looks for the IP address of the default router. The IP address of the router becomes the logical address that must be mapped to a physical address. The third scenario is sender is a router that has received a datagram destined for a host on another network. In this case, the router checks its routing table and finds the IP address of the next router. The IP address of the next router becomes the logical address that must be mapped to a physical address. And the last case is the sender is a router that has received a datagram destined for a host on the same network. In this case, the destination IP address of the datagram becomes the logical address that must be mapped to a physical address. So that's all about ARP. Thank you.